For over a century, electricity has followed the same basic system. Power plants generate energy, transmission lines carry it, substations distribute it, cities consume it. That model built the modern world. But today, something quietly revolutionary is happening. Across deserts, coastlines, and industrial zones, engineers are constructing massive energy storage facilities so large they can power entire cities without relying on traditional grids. Not coal plants, not nuclear reactors, not hydro dams, batteries. Mega battery systems the size of football stadiums. Energy storage hubs capable of holding gigawatt hours of electricity. Facilities designed to stabilize power networks, prevent blackouts, and in some cases replace aging grid infrastructure entirely. And once you understand how this system works, you'll realize something shocking. The future of electricity may not depend on producing more power, it may depend on storing it better. So what exactly is this mega battery project? Why are governments investing billions into it? And how could it fundamentally change the way cities receive electricity? Stay with this video, because what you're about to learn could redefine how civilization powers itself. Number 1. Why the power grid is failing. Modern power grids were designed decades ago. They were built for predictable demand, centralized power plants, and slow population growth. But the world changed. Electric vehicles multiply every year. AI data centers consume enormous amounts of electricity. Smart cities require constant digital infrastructure. Heat waves overload cooling systems. Extreme weather damages transmission lines. The grid was never designed for this level of pressure. In many countries, blackouts are becoming more frequent. Maintenance costs continue rising. Transmission lines are aging. Energy losses increase over long distances. In some regions, up to 10% of electricity is lost before it even reaches consumers. That's wasted power, wasted money, wasted efficiency. Engineers realize the problem isn't only how electricity is generated, it's how it's managed. And that realization sparked the mega battery movement. Number 2. Storage is becoming more important than generation. For decades, the solution to energy demand was simple. Build more power plants, burn more fuel, increase production. But renewable energy changed the equation. Solar panels only work when the sun shines. Wind turbines only generate power when the wind blows. This created a serious problem. At noon, solar farms often produce too much electricity. At night, they produce nothing. During storms, wind output spikes. During calm weather, production collapses. Energy supply became unpredictable. Mega batteries solve this by storing excess energy when production is high and releasing it when demand rises. Instead of wasting electricity, it is saved. Instead of building more power plants, energy is balanced. Storage transforms renewable energy from unstable to reliable. And that makes batteries just as important as power stations. Number 3. What exactly is a mega battery system? A mega battery isn't one giant battery. It's a massive network of thousands of industrial storage modules working together. Some use lithium-ion chemistry. Others use iron-air systems. Some rely on sodium or liquid metal technologies. These facilities can store enough electricity to power hundreds of thousands of homes for hours or even days. They are built near cities, near solar farms, near wind parks, near industrial zones. Instead of sending electricity across long transmission lines, energy is stored locally and distributed instantly. This creates decentralized energy hubs, small independent systems that can operate even when the main grid fails. During outages, hospitals remain powered. Data centers stay online. Transportation systems continue operating. Energy security becomes local instead of distant. Number 4. How mega batteries replace power plants. Traditional power plants generate electricity on demand. When usage increases, they ramp up production. When demand falls, they slow down. Mega batteries flip this model. Instead of adjusting production, they adjust storage. Energy is collected during low-demand periods. It is released instantly during peak usage. This creates ultra-fast response capability. Gas power plants take minutes to react. Batteries react in milliseconds. This stabilizes voltage, prevents grid crashes, smooths sudden demand spikes. In many regions, mega batteries are already replacing peaker plants. These are fossil fuel stations that only operate during high demand and produce heavy pollution. Replacing them saves money and dramatically reduces emissions. Number 5. The scale is bigger than most people realize. When people hear the word battery, they imagine phones or electric cars. Grid-scale batteries operate on a completely different level. Some installations store more than 1 gigawatt-hour of electricity. That's enough to power an entire city district for hours. Future projects aim to store multiple gigawatt hours in a single facility. These sites use thousands of battery containers stacked in climate-controlled warehouses. AI systems monitor temperature, charging cycles, and demand patterns. This is not consumer technology. This is national-scale infrastructure. Number 6. Why governments are investing billions. Governments understand one critical fact. Energy stability equals economic stability. Mega batteries reduce dependence on fuel imports. They stabilize renewable energy supply. They protect cities from blackouts. They improve disaster recovery. During storms and earthquakes, power grids often fail. Battery-based microgrids allow communities to remain operational even when central infrastructure collapses. This is why governments around the world are accelerating energy storage projects. It's not only about climate goals, it's about national resilience. Number 7. How cities will change. Mega batteries allow cities to operate differently. Instead of relying on distant power plants, cities can become partially energy independent. Solar panels generate electricity locally. Batteries store it locally. Consumption happens locally. Transmission losses decrease. Infrastructure costs drop. Outages become rare. Urban planners are now designing energy-adaptive cities, neighborhood-level storage hubs, battery-supported public transportation, emergency power systems integrated directly into city networks. The city becomes its own energy organism. Number 8. The economic impact. Mega battery deployment is reshaping the energy economy. New manufacturing industries emerge. Energy jobs evolve. Utility business models transform. Instead of selling only electricity, companies sell grid stability services. Battery operators earn revenue by balancing demand, preventing overloads, and providing backup capacity. Energy becomes flexible instead of rigid. Markets shift from generation-focused to storage-focused strategies. Number 9. Environmental impact. Replacing fossil fuel peaker plants with batteries reduces pollution significantly. Gas plants burn fuel inefficiently during peak demand. They produce high emissions for short periods of operation. Mega batteries eliminate this need. They allow renewable energy to cover demand spikes without burning fossil fuels. This reduces carbon output, improves air quality, decreases water usage required for cooling power plants. Energy becomes cleaner and more sustainable. Number 10. The technical challenges. Mega batteries are not perfect. They face serious challenges. Battery degradation over time. Raw material supply limitations. Thermal management risks. Recycling infrastructure gaps. Engineers are developing new chemistries that rely on cheaper and more abundant materials like iron and sodium. Recycling technologies are improving, allowing old batteries to be reused instead of discarded. The technology is evolving rapidly. So when you hear about giant battery projects being built around the world, understand this: they are not backup systems. They are not temporary solutions. They are the foundation of a new energy era, one where storage replaces power plants, where grids become intelligent networks, where electricity flows without interruption. The mega battery revolution is not coming. It's already happening. Now tell me in the comments, do you trust massive battery systems to replace traditional power grids? Or do you think centralized power plants will always dominate? And make sure to subscribe, because the future of energy is being rewritten right now.